Okay, so this question, it's a circle theorem that we haven't covered. It's actually quite nice in that it's actually related to similar triangles. So if I bring it to a basic version of the question, what we're doing is we're actually saying a theorem about intersecting chords. Now, you can prove the following statement, that if I complete AF, come on, give me the blue pen. If I do the line AF and the line EB, that should be, what can you tell me about the two triangles I've created?
They're similar?
They're similar. They must be by a scale factor. Vertically opposite angles say these two are equal. Angles are equal. If you connect the lines BF, then by alternate segment theorem, these two angles, A and E, are equal. Do the same thing between A and E, and then you can say the angle at B and the angle at F must be equal. So they are similar triangles. Okay? Similar triangles, what can you also say about them?
That if you have that FE equals AB.
Doesn't equal. What you're saying is
that
that...
equal, they can be solved in ratio.
Yeah, they're in a common ratio. So the similar sides, E and A, is in the same ratio as the similar sides go from the same triangle, B and F. And that's actually also equal to the scaling of going from XEB to XAF. If you look at this ratio, we can actually say EF is equal to AB. So if you've got two chords intersecting, the product of the two lengths either side of the intersecting point in both chords must be the same. Now we're going to use that twice. Once classically, then one doing a bit of a fudge. We use this and go around and work in the other question. So I've got a length AF, and the other part of that chord is FB. Yeah? It intersects with a chord that does DF, and that also intersects with F all the way through O and out the other side. So a point I'm going to call D dash, just to keep them together. So that's the things I'm saying are equal. Yeah? So I now need to write an expression. AF is easy, that's 7. FB is 4. DF we know is 2. And FD is right across the circle, known as what's right across the circle called?
Through the center.
Yeah. So right from D through the centre to D dash, what's the name of that line? Diameter. If we know this OE you were talking about before, that's what's OE? Because this is one of the things we need.
Half of
Diameter, normally known as
radius.
Radius. So this F to D dash, it's the diameter, which is 2r, but less 2 centimetres to go from F to D dash. Yeah? That's the two parts of my segment. So now if I multiply this through, I've got 28 is equal to 4r minus 4. So 32 equals 4r. So r is 8 centimetres. Yeah? We now know r is 8.
Wait, why did we do 2 times in the beginning if we're minusing 2? Oh, wait,
That one is because we want to go from the F to the D. Well, we can't actually say anything about this length, but we can say that DO is a radius. OD dash is a radius, so that's the 2r.
Yeah.
But we only wanted to go as far as F, so we're 2 centimetres shorter. That's why we get the 2r minus up to. Yeah? In this question, that's only worth 2 marks out of 5 so far. To get the point to go to X, we have to do something similar. So I'm going to change colour and continue in another colour. So coming out here, we need to extend this one. Come on, change the colour. So we've got a similar setup actually. It's a bit weird though. These two things are still chords. And they still intersect outside of the circle.
Why is E to O a chord?
E to O.
You just
It's
said-
not a chord, I said all the way through. And I've extended it out as a chord.
Oh.
Yeah, so the chord is actually a diameter, but a diameter is just a special chord. So we've now actually can do the same ruling. The fact it's outside, I'm going to do a little bit of funny. The mark scheme for this question doesn't show it, and I haven't seen this in the textbooks for years. But this is the way I remember I was told to deal with this situation. So I've got, here's my chord, is AC. That's going up to the point where they meet. Yeah, so AC is this chord to the point where they meet. And I've got to multiply that by the extension of this back to the circle, which is BC. Okay, that's a bit weird, I know, but it's the same chord, it just has been extended outside, and instead of crossing inside the circle, we're crossing outside. Do the same thing on the other one. The major chord is C to E dash, and the minor chord is the C to E. Okay? So in both cases we're coming out to the point C is the place. So AC is 7 plus 4 plus 5. Yeah? BC is a 5, and the only reason I'm putting the minus on there is to show it's outside the circle. In a minute you're going to see it disappears. So C to E dash is X plus 2 R's. Now we know what R is now.
Plus 16.
Yeah, so we're going to plus 16. Times the length CE, which is X. Yeah?
Aren't you going to do minus X?
So yeah, yeah, good. He cottoned onto the idea. It's outside. We've got a minus X because it's outside the circle. The minuses cancel. Doesn't matter. But the reason I put it in is to show you outside.
In the exam question, should we show the minuses?
They don't care. Mark scheme didn't show it. That's partly what confused me when I was looking at it. So we go through the numbers and we add this up. We've got 5, 9, 16 times 5, which is 80. X squared plus 16x. And now we've got a quadratic to solve.
So X squared 16x
Minus 80 must equal 0. Can we find some factors for it? I don't think it does factorise. No, I can't think of any factors close quickly. So use the formula. X equals minus b plus or minus the square root of b squared minus 4 times a times c.
So
4
this X equals
times
4.
times a, which is 1 times minus 80, all divided by 2 lots of a, 2 times 1.
So it's minus 20 and 4. That's what I
Did it come out as a whole numbers? Didn't think it came out as whole numbers. You've got 320 plus 256. It's 576. That does square root, doesn't it? So 16 square. I'll tell you what, I'll use my white calculator because it solves quadratics for me. Where's my white calculator's gone? Oh no, I haven't got it handy. So 16 squared minus 4 times 1 times minus 80 576, square root that number. It is 24, so it's minus 16 plus or minus square root of 24 divided by 2. So yeah, you're going to get minus 20 or 8, 4. So we're now saying x must be 4 centimetres. Okay, so they applied this same new intersecting chords trick twice, once in a normal way and once in a very weird way. All right with that?